See, what is that till previous class we went out with is flux change happens in a coil, and due to the change of current in the same coil, flux linked with the same coil changes, and an EMF is induced in that coil, and that produces an EMF, and which you call as self inductance. Now, in this case, you take this is called primary coil. Remember, just by changing the resistance here, I am changing the current inside this coil. By changing the current in this coil, I am changing the flux linked with this coil. And this coil or this flux linked with the coil or the flux generated by this coil is also linked with the other coil, which is called secondary coil. Now, what I am doing here is just by changing the resistance, I am changing the current in the primary coil. Because of the change of current in the primary coil, flux linked with the secondary coil is changing, and hence an EMF is induced in secondary coil, and hence current flows through it. And this phenomena is what we will call as mutual inductance. Aditya, what is the difference between mutual inductance and self-inductance?
Sir, in self-inductance, due to the in current, by itself, what will say?
Yes,
Uh,
yes, correct. Mutual inductance?
the coil is getting induced.
Right. In mutual inductance, when current in the primary coil changes, comma, flux linked with secondary coil will change. This results an induction of EMF in secondary coil. If it is closed, a current will be induced. This phenomena is mutual inductance. In fact, a transformer works on this principle. A transformer works on this principle. You can see here in this case only, there is a primary coil, there is a secondary coil. They are closely wound coils. For example, a current I1, for example, a current I1 is passing through the primary coils. Let there be N1 turns in the primary coil. Let there be N1 turns in the primary coil. And let there be N2 turns in the secondary coil. Here, the magnetic flux caused by the current in the primary coil. I repeat, magnetic flux, okay, caused by the current in the primary coil. Magnetic flux caused by the current in the primary coil, and that passing through the secondary coil. that which passes through the secondary coil. Remember, magnetic flux caused by the current in the primary coil and that passes through the secondary coil B, we will use a terminology called phi12. This phi12 is proportional to current in the primary coil. Current in the primary coil. And this phi12 into N2, because per turn this is the flux. And the whole thing is a constant M12 times current in the primary. And this constant of proportionality is called coefficient of mutual inductance. MI means mutual inductance, not what you call moment of inertia. Remember, mutual inductance depends on number one, geometry or orientation of one coil with respect to other. That is one factor, a geometry factor. Two, number of turns in secondary coil. That's it. So now in this, what is the fundamental definition? What is the fundamental definition? Where in self-inductance, EMF is minus LdI by dt. Here, EMF generated due to mutual inductance is given as minus M12 di primary by dt. Remember, there di by dt is what you have written. Here, you will write it as di primary by dt. Okay. Similarly, vice versa also, if you make secondary as primary, it will become di secondary by dt. Vice versa also. So therefore, mutual inductance point of view, there is no difference. You can write M12 is same as M21. This is called reciprocity theorem. I'll prove this later. So, ante now you are assuming in your analogy, you are assuming that this is primary and this is secondary. If you choose this as primary, this as secondary, same rules will work. The same setup I'll fix over here, and the same magnet current sensitive meter I'll post here. Result is the same. So mutual inductance is that part. So both mutual inductance and self-inductance will have same units. They will have same units. Right. Actually, I just want to post one more information also for you before I do with this problem. For example, you have an arrangement like this. You have one arrangement like this. So this is coil 1. You have another arrangement like this. This is a coil 2. This is a coil 1. This is some iron rod. Here, mutual inductance is proportional to, here mutual inductance is proportional to L1 and L2, where L1 and L2 are the respective self-inductance. And M is some constant K times L1, L2. This K is called coefficient of coupling. See, this is called tight coupling, where there is no leakage of flux. In case of loose coupling, K will be less than 1. In case of tight coupling, K is equal to 1. I'll discuss this much more uh, depth later stage. Just for your information, mutual inductance also depends on their respective self-inductances. That is also one point that you need to know. Next. Now see the question. A long solenoid with circular cross section of radius R1. Can you see that in the diagram? Can you see that this is R1? Okay. And N turns per unit length is inside another coaxial with a short coil with circular cross section R2 and N turns. Current in the solenoid is increased at a constant rate from 0 to I over a time interval of T. You can see this is the solenoid and this is the short coil. See, if an observer is standing here, he will see this picture. Right. What do you want now? I want a mutual inductance. What is the formula for mutual inductance? Mutual inductance is number of turns of secondary into flux linked with the secondary coil divided by current in the primary coil. You have any doubt in this? Just ask me now. Aditya, any doubt?
No, sir.
Pakka, are you following now?
Yes. Yes, sir.
Right. Right. So you are following, right? Good. Next, Palvita attended. No. Worst situation here. I still. अरे क्लास అయిపోయిందా మ్యాథ్స్ క్లాస్ ఆదిత్య
Yes, sir.
నెంబర్ ఆఫ్ టర్న్స్ ఇన్ సెకండరీ ఫ్లక్స్ లింక్డ్ విత్ secondary divided by current in primary. Now, what is the flux linked with the secondary? This is nothing but B. There is no field outside the solenoid. I know that. B into pi R1 square. Right. pi r1 square. What is B? Are a solenoid, mu naught, n turns per unit length, n I primary, that's all, because it's a long solenoid, into pi r1 square. Boys, do you have any doubt in this substitution?
No, sir.
Pakka. Proud. Now
Yes.
clearly ns is given as n. I primary already you know. So what is mutual inductance? ns phi s by ip, which is nothing but n primary by pi r1 square by I primary, mu naught capital N pi r1 square. That's the deal. Right. Any doubt? So here I have given the mutual inductance. Area, whatever, whether it current goes n times, that I don't care. What do you want? Find the mutual inductance. Then next, find the mutual inductance between the coils and potential difference induced in the shorter coil. EMF in the secondary is, you want magnitude term only, no? Because you didn't given any direction, all that things. It is nothing but M times di primary by dt. But fortunately, di primary you have given as an information 0 to I over a time interval t. So this is I by t. So which is nothing but mu naught n small n pi r1 square I divided by t. Boys and girls, do you have any doubt?
No, sir.
Gaurav, have you followed?
Yes, sir.
Right. Manikanta,
Yes, sir.
thank you. Right. This is done. So we'll move on to the next question. What is our next question? Hold on. Let me. I'll close mutual inductance today by hook or crook. Lot of questions were there actually. Okay. A rectangular wire frame with side A and B is placed near a long straight wire and a rectangular frame with side A. Right. You can see that, right? L distance. Mutual inductance of a long straight wire and a rectangular frame. See, if you permit me, this is an infinite long straight current carrying conductor. Besides, you have a rectangular coil AB. And they are separated by a distance L. Now you see, you have an element shown here. You have an element shown here. Say, for example, all this is an inward magnetic field. I think we have done this n number of times. Now, flux linked with the secondary is integral mu naught by 2 pi I by x, and it is BDX. It is L to L plus A. Phi secondary is mu naught I B by 2 pi log E L plus A by L. That is the flux linked with the secondary. And what is mutual inductance? Simple. There is no number of turns, single loop. It is a single loop. So phi with the secondary by I primary. I primary is this. So by the way, mu naught B by 2 pi log E L plus A by L. Boys and girls, do you have any doubt in this? Please ask me. Mu naught B by 2 pi log E L plus A by L. Do you have any doubt? Please ask.
No, sir, no doubts.
Right. And next case, before I discuss, I need to discuss a point. Mutual inductance for a combination. If, for example, I have an arrangement like this. You have an arrangement like this. In this situation, the flux linkage ఇప్పుడు చూడండి, ఇక్కడ అవుట్ ఈజ్ సేమ్ యాజ్ దీని ఇన్. అంటే దాని అర్థం ఫ్లక్స్ లింకేజ్ ఆర్ ఇన్ సేమ్ డైరెక్షన్. అయితే ఏంటి సార్, ఇది ఫ్లక్స్ లింకేజ్ ఆర్ ఇన్ ద సేమ్ డైరెక్షన్ ఎట్ ఎనీ ఇన్స్టెంట్. Flux linked with the first coil. Sir, already we know, true, you know, what you know is L1, I1 till yesterday. Because that time there is no second coil. Now you have a second coil. Mutual inductance times I2. Agreed or any doubt? Boys and girls, agreed or any doubt? Similarly, this is the flux linkage with first coil. Flux linkage with coil 1. Now I am dealing with flux linkage with coil 2. Flux linkage with coil 2. L2 I2 plus Mi1. Flux linkage with coil 2. Now, if the currents are changing, what is the EMF induced in the first coil? Magnitude d phi 1 by dt. You will call this as L1 di1 by dt plus m times di2 by dt. E2 is d phi 2 by dt is L2 di2 by dt plus m times di1 by dt. That is how you will write the EMFs induced. Remember, what is the condition that allows all this. Flux linkages are in same direction. What if the flux linkages are in opposite direction? I'll just show you another situation where flux linkages are in opposite direction. In this, you can see inward, outward, inward, outward. You can see here in this particular zone, the fluxes are against one another. So here, what I can write is, what I've written here, flux linkage are in the same direction. Flux linkage are in opposite direction. So how to write? Can anyone help me in writing 5-1 now, please? Anyone in the class?
L1 I1 minus MI2.
Very good, Aditya. Aditya, you are super. MI2. Similarly, 5-2 is L2, L1 I1 kada, L2 I2 minus MI1. Similarly, in the same case, you can write EMFs also. Therefore, induced EMF is, I'm straight away writing d phi 1 by dt is L1 di1 by dt minus m times di2 by dt, and E2 is d phi 2 by dt, which is L2 di2 by dt minus m times di1 by dt. That's the difference. Now tell me, please, have you understood very clearly about, apart from this, there is no different arrangement. Apart from this, there is no different arrangement. So when two coils are side by side, the problem is, when two coils are side by side for you, the problem is, it is possible that the mutual inductance of the system is also to be considered. There is an IIT question I might discuss very soon, right now, very soon. IIT question, actually, that is an IIT question. I'll discuss definitely. But before that, I need to discuss some basic models related to mutual inductance. Definitely, I'll discuss the IIT question, undoubtedly. That is a very, that time, if I remember, year 2020, if I'm not mistaken, year 2020, I think you have that particular question. Very good question, actually. Lot of students confused, first time doing that, no? Confused and failed also in doing that particular question. Remember, when you wish to apply the concept of mutual inductance, never forget mutual inductance concept is strictly applicable only under one condition. What is that? The current needs to be variable. If the current is steady, you don't find mutual inductance effect at all. It means, for example, a transformer actually works on the principle of mutual inductance. But how transformer works? It works with alternating currents, not with steady currents. Everyone try to please understand this particular thing, because now I am going to give you that whatever mutual inductance part, what I said, IIT questions, there are 3 questions in IIT, only 3 questions, maybe for a gap of 10 years. Very rarely it will be questioned. Now, this is the question I'm speaking about. A very good question according to me. Everyone try this. The inductors of two LR circuits are placed next to each other as shown in the figure. The values of the self-inductance, the values of self-inductance of the inductors, arrangement, resistance, blah, 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 all that they have given. Now here, the sense of current, I am assuming it like this. Like this. So I am assuming, see, for example, I am drawing only the inductors part. For example, you have the inductor arrangement like this. Like this. So which means now it is going on like this. Sir, fine, what is that you are doing? Hold on here. Now here what is happening is the flux lines are going like this. And the flux lines are passing like this. Aditya, which case will this come under? Plus case or minus case?
Plus case, I guess.
That is why I have drawn all these things. So therefore, in the first case, if you want EMF induced in the first case, you will write this as L1 di1 by dt plus M times di2 by dt. E2 is equal to L2 times di2 by dt plus M times di1 by dt. Fine. Who asked all this? What is that they are asking? Work done by the batteries against the induced EMF. Fine. What is the work done by the batteries? The work done by the batteries are dW1 plus dW2. Agreed, boys and girls? dW1 means earlier EMF, current, its power, dt, plus EMF, current into dt, power into dt, time. So by the way, what is that I am going to get? The moment when I substitute everything over here, I'll get L1, I1, di1 plus M, I1, di1 plus L2, I2, di2 plus M, I2, di1. So now which is L1, no, the area L1, I1, di1 plus L2, I2, di2 plus, if you permit me, I will write this as MD I1, I2. Now I am stopping here. Aditya, tell me, is this clear or not?
Yes, sir.
Right. That is not the work, small amount of work. So therefore, finally, total work is integral dW. You will get L1 I1 square by 2 plus L2 I2 square by 2 plus M times I1 I2. This is what you will get. You just substitute the values given in the question. Everything they have given. Everything they have given. So by substituting, you will have all the values. I1 is, how do you get I1? I1 is the steady state current. 5 volts, 5 volts, 5 ohms, 1 ampere. I2, 20 volts, 10 amps, 2 amperes. L1 is given as 10 millihenry. L2 is given as 20 millihenry. And W is equal to 55 millijoule. Next. That's the question. Any doubts? See, lot of students failed in doing this question, lot of students. One more question is also there. That also I'll discuss. A very, 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 very good question. This was asked in 2016. Is this clear, by the way? Boys and girls?
Yes, sir.
Right. So, in this previous IIT type question, what you have is a conducting loop in the shape of a right-angled isosceles triangle of height 10 centimeters, which is kept at 90 degrees. Vertex is close to the infinite long conducting wire. The wire is electrically insulated from the loop. Okay, fine. And the current is changing at a rate of 10 amperes per second. Which of the following statement is or true? Right. In this, try to please understand. You just imagine the flux linked by this loop, by this current carrying conductor with this triangular loop. So how to get that? I'll give you the expression. You said this is 90 degrees. Fine. Right. Right. Now, in this, I am assuming the current like this that allows an inward flux here. See, at some distance, x, what is going to be the flux? Flux is mu naught by 2 pi I by x. Fine. That's the field. And here speaking about this zone. It's this zone, right? Remember, this is 45 degrees. 45 degrees. Are bhaiya, if this is x, this is also x. So 2x dx. Right. Now integration. By doing the integration, you will get a condition mu naught I by pi. Mu naught I by pi. Right. Any doubt till this point?
No.
Because that is a flux. Now, mutual inductance is what you want. Are increased at a constant rate of 10 ampere per second. You don't know current, but the rate of change of current is what you know. Hold on, that I'll take it later, no issues. And what are the options for this? First of all, Yeah, let me handle it like this. Due to this current carrying conductor, there is an inward flux, increasing flux. So left hand thumb into the plane. So you will get a current like this, and like this. So I am assuming that this is how the current goes. No, but remember, this is at a farther point. This line is at a farther point. These lines are closer and they are in opposite direction to the main. So definitely they will experience mutually repulsive forces, right? They'll experience the repulsive forces between the wire and the loop. That's fine. Next part. Here, flux in the secondary is mu naught by pi times current in the primary. So this term is going to be mutual inductance of the combination. What is the induced EMF in this wire? What is the induced EMF? What is the EMF induced, first of all? Mutual inductance times di primary by dt. Mu naught by pi times current changes as mu naught by pi into 10. I think a triangle of height 10 centimeters actually. 2x dx, everything is fine, right? Either one point we have missed. Integral dx is some the total length L, no? L or H, L or H. As L we are using for inductor H. H is 10 centimeters, means 1 by 10. In that case, mu naught by 10 pi becomes mutual inductance. 10 pi into 10. So the EMF induced is mu naught by pi. Yes, magnitude of the induced EMF is mu naught by pi volt. Right. If the loop is rotated at a constant angular speed about the wire, additional EMF wrong. Why? Because it is not, there is no change of flux. Same number of lines will pass through. You rotate the triangle about taking the line as the axis. There is no change of flux. So there is no change of current, or there is no additional induction of EMF in this. The EMF induced only because of the mutual inductance effect. Right. Any doubt in this? Please ask me. Aditya?
Sir, no, sir. No doubt.
Any other student? Why Aditya alone? Because Gaurav? Harsh? No one is answering? Right. Right. That is also a previous IIT question actually. All these are previous IIT. గొడవ చేస్తున్నారు సైలెంట్ ఉంటున్నారు గట్టిగా మాట్లాడుతున్నారు క్లాస్లో ఉన్నా నెక్స్ట్ that is one more question which is my favorite question. A lot of times you will face this question. Test. Yes. What is going to be your answer for this? In the figure shown, mutual inductance of a coil and a very long straight wire is M. Combination as M. అరే యార్ ఇప్పుడే చెప్పారు కదరా నాయన ఫ్లక్స్ లింక్డ్ విత్ ది సెకండరీ ఈజ్ మ్యూచువల్ ఇండక్టెన్స్ టైమ్స్ ఐ ప్రైమరీ. ఎనీ డౌట్ టిల్ దిస్ పాయింట్, బాయ్స్ అండ్ గర్ల్స్?
No, sir.
Right. Right. What do you want in this question? 25 here it is the EMF part. The current in the wire. No. See, issue is that there is a source of EMF in this. There is an inductance also in this. Actually, I should understand, in fact, you should understand that's the duplication of this circuit is, oh, first of all, please, sir, what is the direction of the flux, inward flux? And changing positively. So therefore, inward, left hand thumb into the plane of the paper, turn of the rest of the four fingers is anti-clockwise. M di primary by dt. M di primary by dt. The differentiation of that gives you a M into A. Rest everything is your old circuit, LR circuit, growth of current in LR circuit. What is the formula for growth of current in LR circuit? I is equal to I naught 1 minus e to the power of minus t by tau. So which is nothing but I is EMF, maximum current is M into A by resistance. 1 minus e to the power of t by tau. By the way, what is tau? L by R. Yes, boys and girls, do you have any doubt in this?
No, sir.
Paka.
Yeah.
Right. One more. Mutual inductance based. Actually, a lot of questions were there, but we are just doing introduction part only today. Right. No issues. Now, see, basically try to understand. 2 days onwards, I am not discussing one concept, series combination of inductance. You know why? Because to explain series combination of effective series combination of inductance, you need to have a knowledge on mutual inductance also. You may ask me, how are they related? I will explain. See, if mutual inductance is not taken into account, we have a different situation. If mutual inductance is taken, we have a different situation. I will explain that in simple manner. Series combination of inductors. Series combination of inductors. Let us take a situation where the linkage is such that the linkage is like this. In this case, flux are linked such that they are in same direction. Flux linkage is in the same direction. In this case, what will happen at any instant, if you ask me what is the potential drop across each circuit, I'll simply say this is V1 plus V2. Here our V1, just now we have drawn E1 plus E2, no? So L1 di by dt plus M times di by dt plus L2 di by dt plus M times di by dt. Sir, why you are writing di by dt? Are it series? Whatever the rate of change of current happens in L1, it's the same rate of change happens in L2. So finally, you can write it as L1 plus L2 plus 2M times di by dt. You know, this is called L effective di by dt. So in this combination, L effective is L1 plus L2 plus 2M. Even though they are in series, it is how you need to write. Similarly, there is another combination also possible. In that combination, flux is opposite to each other. Flux is opposite to each other. Right. This is the case where flux is opposite. You can see it is how it was supposed to go due to the first one. They are actually opposite now. So there, in that case, what is going to happen when you are writing V1 plus V2? Flux linkage is opposite here. Flux linkage opposite. So in this case, you will write it as L1 di by dt minus M di by dt plus L2 di by dt minus M di by dt. L1 plus L2 minus 2M di by dt. So this is L effective di by dt. So therefore, in this case, L effective is written as L1 plus L2 minus 2M. Okay. So series combination of inductors, you have a situation like this. Any doubts? Aditya?
No, sir.
Suppose
No, doubt.
inductors are far separated. The inductors are far separated. In that case, mutual inductance tends to 0. In that case, L effective is simply L1 plus L. That is about series combination. Similarly, if you have a parallel combination, if mutual inductance is not considered, simply you will write as 1 by L1 plus 1 by L2. If mutual inductance is not considered, easy. Mutual inductance is considered, then you have a problem. Parallel combination of inductors. Right. So let us take one such example where you have parallel combination of inductors. In this situation, how they were coupled is also important. For example, you take a case like this. There is some mutual. Just now we have done this question. Just now. Okay. In this case, at any instant, what is the potential difference across the first inductor? You will simply write minus L1. In that, the current is di1 by dt minus M di2 by dt. Similarly, delta V2, both are same, of course, minus L2 di2 by dt minus M di1 by dt. Just to know, we have done a previous IIT question. Now, what is happening here? You are assuming a current I1 is passing over here, I2 is passing over here. So with this small, we will write here delta V1 or delta V2 is the same, let it be delta V, because parallel combination. So I can write minus di1 by dt from these two equations as delta V by L1 on the basis of the first information plus M by L2 1 di2 by dt. Right. This is what I can write on the places of minus di1 by dt. Now use this in any of these equations. Now let this be equation 3. Let this be equation 1. Let this be equation 2. Now I am going to use equation 3 in equation 2. This allows me to write as minus L2 di2 by dt minus m, or your substitution of this becomes plus minus di by d1 kada మీరు రాసేది m delta v by L1 plus m by L1 di2 by dt. Right. Are you properly writing this, you will get the condition minus L1 L2 minus L1 L2 plus m square di2 by dt is equal to delta v L1 minus m. Ariyar, don't worry, I will never ask you derive all these things. Now you got minus di2 by dt. So you got minus di2 by dt as delta v by L2 plus m by L2 times di1 by dt. Ariyar, with all these combinations, you will prove that minus L1 L2 plus m square di by dt is delta v times L1 plus L2 minus 2m. Remember, I've used all these equations. Basically, I am going to write only one thing here. Delta v is minus L effective di by dt. I am going to get this information. So therefore, delta v is some constant. It is like L1, L2 minus m square by L1 plus L2 minus 2m times. The minus I am writing it add di by dt. Now tell me, L effective place, I have L1, L2 minus m square by L1 plus L2 minus 2m. మీకు బాగా గుర్తు ఏంటంటే న్యూమరేటర్లో m స్క్వేర్, డినామినేటర్లో 2m, బట్ రెండు మైనస్లే. Okay, in this case, if m tends to 0, suppose if the inductors are far apart, if m tends to 0, L effective becomes L1 L2 by L1 plus L2, similar to our resistances. Inductance negligible. It is like L1 L2, 1 by L1 plus 1 by L2 is 1 by L. Aditya, any doubt?
No. Sir.
You don't require to derive all these things. You just need to remember this and draw this. How to remember this? First part is easy. This part is easy, but this part is difficult. Right. So I have just introduced the mutual inductance. In my next class tomorrow, I will discuss hardcore problems. I am telling you again, on Friday and Saturday, I am going to deal strictly Pathfinder questions hereafter. I am teaching fundamental questions for the 2 to 3 days. Attendance, in spite, you see, very poor. 7 students are attending. I will not post this in what you call YouTube. That's all. Right.